This video will show you how to do long division if your divisor has 2 digits in it. Here we have 8,647 divided by 12. In order to solve this division problem with a 2-digit divisor, I'm going to use what's called a doubles table, and I'll show you how to set that up now. On the left side of our doubles tables, we have our numbers 1 through 9. On the right-hand side of the doubles table, we're going to pull our divisor of 12, and we're going to write that down right here next to the 1. That's our divisor. Now, in order to go from 1 to 2, we double it. We double 1 to get 2. So in order to get the number that's next to the 2 over here, we do to this number what we did to this one. To go from 1 to 2, we double it. So to get this number here, we double 12. And doubling 12 gives us 24. Now you'll notice that the next number is red. We'll skip that for now and I'll come back to it. But in order to go from 2 to 4, I doubled 2. Double 2 gives me 4. So if I double 24, it will give me the number to put right here. So doubling 24 gives me 48. Continuing that on, if I double 4, I get 8. If I double 48, I'll get the number that goes here. And doubling 48 gives me 96. Now to get the numbers in red, to get the 3 and the 5, 6, 7, and 9, I need to do some different combinations of the numbers that I already have. So in order to get 3, I can add 1 and 2. 1 plus 2 is 3. So if I do the same thing on the right-hand side, I'll get the number that goes next to 3. Adding 1 and 2 gives me 3. So adding 12 and 24 will give me the number that goes here. That's 36. Now, if I double 3, I will get 6. So if I double 3 to get 6, if I double this number, I'll get the number that goes here. And doubling 36 gives me 72. Now, there's a couple different options I can do to get 5. To get 5, I could add 1 plus 4, which means to get this number, I could add 12 plus 48. Or to get 5, I could add 2 plus 3. Now in order to get this one, I could add the 24 plus 36. Now, I like that they're right next to each other, the 24 and 36, so I'm going to go ahead and add those two together. And 24 plus 36 is 60. Now to get 7, I could do the same thing. I can combine 6 and 1, 5 and 2, or 4 and 3. Either one of those works. I like the 5 because I'm dealing with a 60. There's a nice 0 in the ones place. So to get 7, I could add 5 plus 2. So to get this number here, I would add what's next to 5 and what's next to 2. So 60 plus 24 gives me 84. Now to get 9, again, I've got different ways to do that. I could get 8 plus 1, 7 plus 2, 6 plus 3, or 5 plus 4. I think I'll do the 5 plus 4 to get 9 on this side, on the right side, because 60 and 48, I like that 0 in the ones place. It's going to be easy to add these two numbers. So 60 plus 48 will give me the number that goes next to the 9, just like 4 plus 5 is 9. Adding that together, I get 108. Now we're going to use this information here in our doubles table to solve this division problem. Okay, 12 times what number gets me close to 8? Well, 8's too small. 12 won't go into it, so we need to take the two digits together, 86. So I look on this column here and I see which number is closest to 86 without going over. And I see it's 84. So 84 is closest to 86. Now how did I get it? Well, I got it by multiplying 12 by 7. So I write my 7 above here. 12 times 7 is 84. I subtract, leaving 2. Bring down the 4. Well, 12 times what number gets me closest to 24? Well, I see 24 is right there. That's as close as you can get. So that's 12 times 2 is 24. I subtract, leaving 0. I bring down the 7, and I look back on my doubles table again, looking for 7, the number that's closest to 7 without going over. And I see that even 12 is greater than 7, so it must be 0. So 12 times 7, 12 times 0 is 0. I subtract that from 7, gives me a remainder of 7. So that's how I use my doubles table in order to solve this long division problem. Here's another example. 9,265 divided by 23. So I've got my doubles table set up on the left. All I need to do is complete it. And I'm going to complete it by first putting next to the 1 my divisor of 23. Remember, in order to go from 1 to 2, I double it. So in order to get this one next to 2, I double 23, which in this case is 46. In order to go from 2 to 4, I double it. So if I double 46, I get the number that goes next to the 4. Doubling 46 gives me 92. Double 4, I get 8. So double 92, I get 184. Okay? Again, it's double, skip those, double. You're not just doubling all the way down. So be very careful about that. So in order to get the ones that are in red, I look at my other numbers that I've got together. So in order to get 3, I can add 1 and 2. So to get the number here, I add these two together, the 23 and the 46. And when I do that, I get 69. In order to get 5, I can add 2 and 3, and that would be 115. In order to get 6, I could double 3, which would be 138. To get 7, I could do 6 plus 1. I could do 4 plus 3. I think we'll do 4 plus 3. That's 161. Cram that in there. And in order to get 9, I could do 5 plus 4, which is 207. Now, using the doubles table, I could do my multiplication, or my division over here. 23 times what number gets me close to 92? Well, looking down the list, right there, 4 gives me exactly 92. So, 23 times 4 is 92. I subtract, bring down the 6. 23 times 0 gets me close to 6. In fact, that would be 0. 6, bring down the 5. In order to get close to 65, looks like 69, that's a little too much, so 46 is it. So that would be times 2. So 23 times 2 is 46. I subtract, leaving me with 19. My remainder is less than my divisor, so I know it can't go in there anymore, so 402 remainder 19. It's a big remainder, but remember my divisor is pretty big too. So my answer is 402 remainder 19. And that's how you use the doubles table to help you solve two-digit divisor problems.